Hey, what's up? Mr. Mias is here. A question that I get a lot is how do I find the sample size for a one proportion confidence interval if all I'm given is the margin of error? So let's take a look at that type of problem. Here we go. So let's suppose that I'd like to take an estimate, take a estimate. I can't, okay, Mr. Mias, can you have proper grammar? What's my n doing way over there? Let's click on this and put an n there. There we go. So suppose I'd like to take an estimate. That's what we're finding, actually. We're finding n. That's crazy that happened. Let me talk about that. So we want to find an estimate of the proportion of students at CSU Stan that drink energy drinks more than 4 times per week. So in order to do this, I'm going to take a randomly selected group of students and I'm going to have them take a survey. Do you drink, just a yes or no question, do you drink more than 4 energy drinks during a week? They're going to answer yes, they're going to answer no, and I'm going to determine the proportion of yeses. That's going to be by point estimator. So I'd like to make sure that my estimate, whatever that estimate ends up being, and when I talk about an estimate, I'm really talking about a confidence interval, but I'd like that estimate to be between a 4% margin of error. So how many students am I going to need to survey so that I make sure that my confidence interval is within a 4% margin of error? So the other question that I have here that I need, the specifics that I need, is how large of my confidence level is going to be. So I need to know, am I going to do a 95% confidence interval, a 98% confidence interval, 99%, 90%? I'll determine that towards the end of this problem here so I can show you how to calculate this. All right, so let's take a look at what that means. So if you go back to a video that I've done on confidence intervals, you'll find that the formula for the margin of error, or actually let me just talk about the confidence. Let me put the confidence interval down. It's p hat plus or minus z star times the square root of p hat q hat over n. All right, this p hat is called our point estimator. All right, this is our point estimator. This is basically what's going to happen when I take my survey. So if I get 60% of people say, yes, I drink 4 energy drinks 4 times a week or more, then that would be my point estimator. 60% is what I'm estimating to be the population. It's just what happens in my sample. This part right here, everything after the plus or minus, that's my margin of error. Okay, so what I would like for this particular problem is I would like this z star, square root of p hat q hat over n, I'd like that to be equal or within 0.04. All right, so I could put greater than or equal to if I wanted to. I want it to be, actually within, so I want it to be less than or equal to. But the higher your n, the smaller your margin of error is going to be. So really, when my n, whatever value of n I get, if I go above that, then it's going to be a smaller margin of error. So I'm just going to put an equal sign so that way it'll make us, it'll make it a little bit easier for us to understand what's going on. Okay, so what I'm going to do is I'm going to put this equal to margin of error. So I want to show you, I'm going to come up with kind of a formula that you can use at the end of this. So I'm going to do a little bit of algebra here. First off, I have a little bit of trouble with this because p hat and q hat, I don't know what my point estimator is, right? I haven't actually done the study yet. So what was the best possible thing that could happen to have the highest variability of standard deviation in this case for my p hat and q hat? That's going to happen when they're exactly the same. So I get a 50-50 split. So I'm going to assume that I'm going to get perfect outcome in terms of 50-50, that there is no difference between the two proportions. So what I'm going to do is I'm going to do z star times the square root of 0.5 times 0.5. Okay, so we're gonna assume that that's what we get out. If it comes out to be different, that's okay because it's not going to change. It's not going to make it any worse, is what I'm saying. Okay, so we're going to want to take the best possible scenario in this case for the highest variability here. So okay, we're going to go, and now I'm going to do a little bit of math. So I'm going to divide by z star, and if you don't like to see a bunch of algebra, then you can fast forward this apart. All right, then I'm going to square both sides. So bring this guy up here. All right, you know what I'm going to do? Can I just do 0.5 times 0.5? Please, that's 0.25. Oops. So I'm going to square both sides. So I'm going to get mo squared. I'm going to multiply both sides by n. So I'm going to get 0.25 equals z star squared times n. And then I'm going to divide all of this stuff over to the other side so I can solve for n. N is what I'm solving for because that's my sample size. All right, so I'm going to have this situation here. All right, and that's my formula. So now I can use that to determine what my sample size is. So let's talk about this particular problem. This problem here, we are going to need to know what confidence level we have, because that's where we get Z star. Remember, Z star comes from the confidence level. So let's suppose this is a 95% confidence. And I know that the Z star for 95% confidence is 1.96. Okay, and that was on a previous video, so if you want to go back, or you can find it on a Z table. Okay, so then I'm gonna plug things in. So n equals 0.25 over the margin of error that I want to have. So I want to have it within 4%, so 0.04, not 0.4. That would be 40%. That is a ginormous margin of error. We don't want that that big. 1.96, and we're going to square that, and we're going to do the math on that in a calculator. So let's, I'll take out my nice handy little graphing calculator or scientific calculator because that works best. I'm going to do 0.25 divided by parentheses 0.04 divided by 1.96, close parentheses, and square that bad boy. And I get 600.25. So I'm going to say I'm going to round up to that, 601 students. All right, so I'm going to need 601 students to make sure that my estimate has a margin of error of at least 4%. Now, I just want to tell you that that's for a 95% confidence interval. If I wanted a 90% confidence interval, I would change my my Z star to the Z that goes with 90% confidence. I think that is 1.645, I believe. And then we would just look. And just real quick, because I don't know if I went over this before. Let me see if I have a T table. Let me see if I have a Z table here. I don't see my Z table. Maybe it's over here. There we go. So actually, it's on the T table. I'll look on a T table. I know it's a T table, but you can look on the T table. See down here. Let me zoom in here. On the bottom of a T table, where you see that says Z star right there. Okay, Z star, and then you just go to your confidence level, and there's 1.645. Hey, that's what I said, right? 1.96 goes with 95%. 2.57 99%. So then that way you can find your Z star for whatever you need for your problem. All right, there you go, guys. That's how you find the sample size for a margin of error. See you soon.